Today's lesson is 1.5 Infinite Geometric Series. This is the last lesson in this unit. What an infinite geometric series is, it's just a series with no last term. So it goes on and on forever. So an example could be like doubling something, like 2, 4, 8, 16, and so on. You'll notice that there is always the ... dots for these, and it's geometric, so it's multiplying by a certain number. It is possible to sometimes calculate the sum of the series even though it doesn't end. This happens in one case, and there's one case where we can't actually calculate the sum. So there's two different types of infinite geometric series. One is called a convergent and one is called a divergent. So what a convergent series is, this is when the sums of a sequence, or series I should say, add up and approach a certain value. So in this example that I have here, this particular series, the sum of the first 5, the sum of the first 7, the sum of the first 9, the sum of the first 10, all seem to be approaching the fixed value of 8. So we would just generalize it and say that it appears that the sum is 8, because these are all really, really close to the value of 8. So you'll notice with convergent series, they all increase very small, the sums, and they all approach a certain value. The second type of series, infinite series, is called a divergent series, and this series does not approach a fixed value. So that's the example that I had on the first set of notes, where we would double or triple something. Because there's no end in sight, it doesn't approach a fixed value, we would call this a divergent series, and we can't actually calculate the sum of something that's divergent. So let's go and do the first example. With the formula. So the formula is very similar to the ones we've been doing. It's actually a little bit easier. So in order for you to calculate the sum, the R value has to be between -1 and 1. So your common ratio needs to be between -1 and 1. If it's not, then you'd say it's divergent, and you would not use this formula. If the R value of your series is between these two numbers, you would use this formula. So it's sum infinity symbol. So the sum of the infinite series is equal to T1, so the first term, divided by 1 minus R. So T1 is the first term, R is what it's going up by, S infinity is your sum of your series. Again, this is super important, hence the star. R must be between -1 and 1 to use this formula. If it is not, then you say it's divergent and there's no sum. So let's look at example 1. It says determine whether each infinite series is convergent or divergent. State the sum of the series if it exists. So our first key for this will be to figure out what our R value is, because right away, if I know what R is, I can tell you if it's convergent or divergent. So to find it, no matter whether there's fractions or whole numbers, if you can't tell by sight, take one term and divide it by its previous term. So if I go -1/3 and I divide it by the previous term, which is 1, when I do this, I just multiply by 1, which I still get -1/3. So that would be my R. So because it's between, -1/3 is between -1 and 1, this would be a convergent series. So it's convergent, which means I can use my formula that I gave you in the previous slide. So I'm going to write down that formula from the previous slide. S infinity equals T1 divided by 1 minus R. I'm looking for the sum, so that's my unknown. The first term in this series was 1, and my R is -1/3. I'll put that in brackets. S infinity equals, can't do anything on the top, so it's just 1. This will be, when you subtract a negative, you end up adding the opposite. So I'm going to go 1 plus a third. And then it's, oh no, fractions. But don't worry, we have to remember common denominators. So a 1, we could write that as 3 over 3, right, to get our common denominators. And then when we're adding, we only add the tops. So if we go 3 over 3 and we add a third to it, we get 4 thirds. 3 plus 1 is 4 over 3. Then at this point, I could keep doing it by hand. I could multiply by the reciprocal, or I could just switch to my calculator and go 1 divided by 4 thirds, which would give me 0.75. Or if I did the non-calculator way, when I flip the bottom, it becomes 3/4, and times it by 1, it's still 3/4. So either way, you'll get the same answer. So the sum of that series seems to be approaching 3/4 or 0.75. So if we kept expanding this with the fractions, we would see that no matter whether we did sum of 4 or sum of 10 or sum of 100, this value is going to just be getting super close to 0.75. It's going to be roughly around 3/4 for each one of those sum values. Let's go try the second example over here. So it looks like my first term is 2 and my second term is -4. So if I go -4 and divide it by 2, I will know what r is, which is -2. So because my r is -2, I can't solve this. It has no sum. So sorry about the pause. R equals -2, so it's divergent, so there's no sum. So luckily for us, we don't have to use the formula. There's no more work to do, so that was easy. There is a your turn. We'd like to try this one and see if it is convergent or divergent, and if you can find a sum or not. So I'll let you try that. I would recommend trying the 1.5 bell work that's in the team's class materials folder, and then I will assign an assignment for you to try through the assignment section of Teams at a later date. Thanks for watching.